everyone, we're going to take a look today at what happens when we're burning food. We want to see, when we burn the food, how much does it change the temperature of the water? So I have Lizzie, my helpful assistant, with me. She's halfway through grad school now, so it's a big moment for us. We're going to burn 3 types of food today. So if you're looking at the online textbook, you are looking at, for activity 3.1, the data table. Now, you'll have to make sure that you are recording data for the water temperature before burning, the water temperature after heating, and then the change in the water temperature. I'm going to show you the setup that we have here. So we've got our ring stand, and you can see we've put this little bit of metal gauze here. This will allow heat to move through it, but it won't let something sink through because this is just a big ring. So we're going to go ahead and do this, and we'll put whatever we are burning, we've put them into these little dishes, and we'll put the dish underneath here, set the food on fire, and then put our water, we have 100 milliliters, in a beaker on top. So we're hoping that that energy, that thermal energy, will come from whatever food's being burned and move up into the water and heat it. We'll be able to detect that because we're looking at temperature using this little probe. All right, so I'm sorry we're not together for you to set things on fire, but I do have Lizzie to do that for us. So Lizzie, I'm going to ask you to start off with the marshmallows.
Sure thing.
So if you could come around this side. We have some marshmallows here, kind of broken them open to look at a better surface area. And Lizzie's going to set them on fire and put them under here. I'm going to take the initial reading of the temperature of the water. And the water temperature before heating is 20 degrees Celsius. I know it's a little hard to see from your angle. We're going to allow that to burn. I don't know if you can see the flames coming up here. And we're hoping that thermal energy from the flaming marshmallows is coming up and transferring through the beaker into the water. We'll be able to see if that thermal energy has transferred by looking at the temperature. So it appears our flame has gone out. I'm looking at the temperature of our water, and it'll be 21 degrees Celsius. So our change in water temperature went from 20 degrees Celsius to 21 degrees Celsius. That's a change of 1 degree Celsius. Okay, so Lizzie, next up we have our potato chips.
All right.
So our water temperature started out again at 20 degrees Celsius. And we're going to allow this to burn until the potato chips are done burning. Something interesting, Lizzie. I've seen this life hack where if you don't have anything to start the charcoal in your grill, you can start it with a bag of potato chips. That would be a cool experiment to know if it's Doritos or Lay's that work best, but don't try that at home without a parent or guardian.
My money's on Cool Ranch.
Cool Ranch. All right, it looks like our flames have gone out. We've got some smoke still coming out here. But, oh, maybe it's still, yeah, there's still just, it's like the coals on a fire, right, for a barbecue, where they start out burning, and then after a while, they're just kind of hot. So we can see, I don't know how well you can see, there's orange glowing there. So one of the things I wanted to mention as we're burning this is that we were really careful to control some of our variables. For instance, in each of these experiments, we're always using 100 milliliters of water, so that we're always having the same amount of water. We've controlled that variable. We've controlled the variable of the distance between the thing that's on fire and the water itself by always keeping that measurement the same. And we've controlled the variable of the amount of food. That's the same for each of these. It's the same measurement we did in grams. So I think you can still see the smoke is just billowing out. There's not a huge change in temperature so far, but there is a change. So we'll get that as soon as it's done. Oh, we should talk about independent and dependent variables here.
Yeah.
I don't know if you know, but we just had an eval on this.
Oh.
In this case, the independent variable, the thing we, the researchers, are changing is what?
The fuel.
The fuel. So the type of food or fuel would be our independent variable. Our dependent variable would be?
The change in water temperature.
Exactly. All right, so it looks like we have finally had our potato chips stop burning, and our change in temperature here, the current temperature of the water appears to be 24 degrees Celsius. So that's a pretty significant change. We went from 20 degrees Celsius to 24 degrees Celsius. So we saw a change in temperature of 4 degrees Celsius. Okay, all right, before we move on, let's talk about other observations that we have. We mentioned that there was a lot of smoke from the potato chips that were on fire. So I've added that to my data table. There was a lot of smoke, and it burned for much longer than the marshmallows did. The marshmallows, I've added that they burn very quickly. It's kind of hard to spot. So our third one, we're going to be burning some oil. Now, rather than set fire to a whole vat of oil, we've measured out the same amount of oil as we did potato chips and marshmallows. We put the oil into this dish, and I don't think you can see it. I'll put a picture up there. But you should notice that there's some paper towel there that we've just kind of wadded up. We've included the paper towel as part of this experiment to make this easier to burn. However, the paper towel burns down, and then once it hits the oil, we're now recording the change in temperature from burning this. So our initial water temperature, the water temperature before heating this time, is once again 20 degrees Celsius. That's pretty standard. All right, Lizzie, if you want to do your thing. Okay. We're going to put that nice little flame just underneath here. And that thermal energy was once chemical energy. The chemical energy was stored in the oil. Now that we've set the oil on fire, we're transforming that chemical energy, we are transforming that chemical energy into thermal energy. Then we're transferring that thermal energy from this dish, from the oil, up into the glass beaker, and then into the water. All right. All right, I'm going to stop our experiment here because even though you can see our flame is still burning pretty brightly here, this has been going on for a long time. Lizzie, you very helpfully edited this and removed about half an hour of time. But we have, altogether, a change in temperature has definitely happened here. The final temperature of this water, we're going to call it, and we're going to say it went up to exactly 35 degrees Celsius. So that's the biggest change of all three. The change in water temperature then would be 15 degrees Celsius. And do you have any other observations I should write down here, Lizzie?
No.
Okay, I would write down that we saw this flame for a long time, right? So it burns for a long time. Is there a lot of smoke?
No.
No, there's not a lot of smoke. Okay. All right, so that's our data for today, and we'll put a picture there. That's our data for today for Activity 3.1. Please remember to take a look at those making sense questions and to answer them in the online textbook. Thanks everyone. See you soon.
Bye.